This is section 6.1 on discrete and continuous random variables. So keep track of the main topic. And we're looking at, the outcomes here are the number of goals a team is likely to score if you randomly selected a National Hockey League team. What is the likelihood that they would have different number of goals in a game? So the random variable, let's highlight that, is X is, you have to define the random variable, the number of goals scored. Okay, and what makes it a random variable is the fact that there's a probability for each outcome. That's all a random variable is. So, and we can do a distribution, which we'll get to. So how do we show it's legitimate? So what are the two things that need to be true to show the probability? This is called, by the way, here's another vocab word for you. This is called a probability distribution. So in the book, like, you'll be asked to make a probability distribution. What is that? It sounds really fancy, but it's simply the outcomes, the list of outcomes, and the probability of getting each outcome. That is a probability distribution. And notice, before we talk about if it's legitimate or not, what's on the y-axis is what's different. It's so important. When we talked about histograms in chapter 1, what would normally be on the y-axis for just a regular histogram? It would be the frequency, right? And it might be a percent, and it might be just the number of outcomes would be the frequency. Now, in a probability distribution, it is the probability. That's what goes on the y-axis when you make a histogram. So how likely is it to get a 2? For 2 goals, it's like 22.8% chance, etc. So for it to be legitimate, what are the two things for this distribution to be legitimate? We need all probabilities have to be between, all probabilities between 0 and 1. And what is the sum of all probabilities? Sum of all probabilities equals 1, yeah. So you would just add them up and show it equals 1. So here we are, and so we can make a histogram of the values in this table, and that's what it looks like. So X is defined as, the random variable is defined as the number of goals scored. Number of goals scored. And then we can find, you're going to want to get used to this notation, we can find the probability that the number of goals scored is greater than equal to 6. So we simply go to the table and add up this plus this plus this plus this, which we can do because it's just a discrete random variable. It's not a range of outcomes. It's just either 6 or 7 or 8. That's what makes it discrete. So we just do 0.041 plus 0.0, this is how you show your work, plus 0.004 plus 0.001, which gives you 0.061. And so that's the probability that you'll have scored greater than equal to 6. Not that likely, about a 6% chance. So now we get into these new symbols, which is what makes this chapter tricky. One of the main objectives for this chapter is finding the mean and the standard deviation of a random variable. What does that actually mean? Well, the mean is like in the activity that you did, it's like, what's the average outcome going to be if I did this many, many times? What would the average outcome be? So the symbol is mu sub x. That means the mean of the random variable x. Mu sub x, or another way of writing it is the expected value of x. So you might see it either way. And to do that, you've already practiced. You take the outcome, like 0 goals, and multiply by the probability of getting that outcome. The probability of getting 1 goal is 0.154. The probability, and then you don't have to list them all. Just put ... And the probability of getting 9 goals is 0.001. Yeah, question, yeah. Oh, this is an E? E, expected value of X? Thank you. Expected value of X. And so you get So on average, if we kept selecting hockey teams and took the average of their number of goals scored, we would get about 2.9. So it means in the long run, which is important to say when you're interpreting probability, in the long run, the average number of goals, GOALS, is 2.851. And now, on average, if I picked a random team, on average, how far away from 2.8 are they going to be? That's what the standard deviation is. So first, to find standard deviation, you first find the variance. And so you're going to see this. Sigma sub x squared. Okay, so let's write that means variance. So we know. The variance is simply what you get before you take the square root and find the standard deviation. That's all. So this is how you do it. It's different than with just a set of numbers when it's a random variable. What you do, but it should make sense why. You take the outcome, like the first one is 0 goals. You subtract to see how far away it is from the mean. Let's just use 2.85. And then you square that, just like you're used to doing. You square the differences. But what you do is then you multiply that by the probability of getting that outcome. So it's sort of like a weighted average in a way. And then you do the next one. You say how far away is 1 from the average squared, because we'll take the square root later. And then multiply by that probability. And we don't have to write them all out. We'll just do the last one, 9 minus 2.85 quantity squared times the probability of getting that outcome. Okay, and so that's the variance. And so sigma sub x is the square root of whatever we get from doing this. The square root of all of this. So let's just do, take all that and throw it in here underneath the square root symbol. And what you will get, I have the final answer is 1.63 goals. So on average, the number of goals will be about 1.6 away from 2.851.